In this video, we will explore building Python scripts against CosmicFrog's Anura data model, with a focus on the CosmicFrog Python library that's been built specifically to enable this. So underneath the CosmicFrog application, we have the Anura data model built specifically for supply chain design. And this enables us to describe our supply chain from where the customers, facilities and suppliers are, which products we have in the supply chain, as well as policies that describe how things move and flow within our supply chain. And this is a standard unified data model across all of our technologies, whether we're optimizing the supply chain, running discrete event simulation, running our Greenfield engine to look at much more strategic structural decisions, or running transportation optimization, looking at vehicle route optimization. And what we're going to focus on in this video is how we can use Atlas, and specifically the CosmicFrog Python library that gives us lots of standard capabilities for scripting against the Anura model, to be able to do really anything that you can do in Python. Chapter 1 is about getting started. We're going to cover installing the CosmicFrog Python library if you're using an external IDE, and we're also going to look at getting connected to your model. So we can build our Python scripts here in Atlas inside the Optologic platform, and we can also build scripts in any other tool of choice that supports Python. And we're going to take a look at both options in this video. So let's start in Atlas, and this is very simple. The first line imports the frog model class from the CosmicFrog library, and then all we need to do is define that the model is equal to frog model, and then define the model name. So in this example we're working with scripting with CosmicFrog, and so all we have to do is just replace the model name, and when you run this script it will know to connect to that CosmicFrog model. Now let's take a look at using an external tool. I've picked Visual Code Studio, and where we're using an external IDE, we'll need to make sure that we install the CosmicFrog Python library. We can do that very easily with pip install CosmicFrog, and that will go download and install the latest version of the library. So connecting to a CosmicFrog model from an external tool is done in exactly the same way, using exactly the same syntax. Model equals frog model, and then we define the name of the model that we want to connect to. Because we're using an external tool, we also need to authenticate, and to do that we use an app key. So we'll create a new file in the same folder as the Python script, and we'll call that file app.key. We can then go back to the Optologic platform, and if you go up to your name and your account, and we go to app key management, and you will most likely already have an app key generated. If you haven't, then you can simply create a new key by entering a name and clicking create key. And then for that app key, you can simply copy it to the clipboard and then paste it directly into the new file app.key. And now when we run this script, it will look for the app.key file and then authenticate us on the Optologic platform, and then connect us to this CosmicFrog model. It is very important to keep your app key safe. It is best practice to ensure it's always in a separate file. Never include your app key directly within your script, as this increases the chances of it being accidentally shared. If you do accidentally share your app key, then you can easily delete it and recreate it in your Optologic account settings. In Chapter 2, we're going to look at working with data. We're going to look at upserting data from external files into the model. We're going to cover CSV and also Excel files. We're going to look at reading data out of the model tables and then being able to use Python to transform it to make changes to that data, and then writing it back into the model to update those tables. Now let's take a look at working with data. So I have a CSV file. It contains my customer data. We can see here that I've got 5 customers, and I want to be able to upload that directly into the customers table within my model. So we can use a CosmicFrog library function, and we can select upsert CSV, and that has 2 parameters. One is the table that I want to insert the data into, which is going to be customers, and the other one is the name of the file that I want to upload, which is my customers.csv. Now I can reference that file directly because it's in the same folder as the Python script, but it may be that if that's in a different location, you would also want to include the path in the file name as well. So now we can run our script, and that will get the data from the CSV file, connect to that model database, And now we can see that it's importing that table, it's picked up the 5 rows, and it's inserted those 5 new records to the model. And if we go across to CosmicFrog, we can now see that within that model, those 5 records have been upserted to the customers table. Now let's take a look at upserting some additional data. So here I've got a CSV file. Customer 4 already exists in our model, so that will be updated. You can see currently there's not a postcode, and in the updated data there is a postcode. But also we now have a new customer, CZ6, that doesn't exist, so this one will be inserted. So now we can come back to our script, and we can see here that this is the file that we want to update our customer table with. So we can change that to updated customers.csv, and we can simply run that code, and that has upserted the 2 records. One row for CZ4 already exists, so that row was updated, and for customer CZ6, which was a new customer, that row got inserted. If we move across to the CosmicFrog model, we can see this is the update to the existing record, and this is the new record that's been inserted for CZ6. So there's no need to clear the data within the table before we do an import. Upsert allows us to upload partial incremental data sets, which will just update the data in the table. Now we're going to look at upserting to many tables at the same time and bringing that data in from an Excel spreadsheet instead of a CSV. And we can see in this Excel spreadsheet, my model data, we've got a sheet for customers, facilities, suppliers, and all the other tables that we need to populate within this model. So let's take a look at how we do that in the script. So we have a model function, upsert Excel, and this will simply take the file name mymodeldata.xlsx, and wherever it sees a sheet name that matches a table, that data will be automatically upserted into our model database. So now we can run our script. It will connect to the model database and process our Excel data, matching a sheet that it recognizes with the table name and importing that data into the model database. So we can see that upsert is now completed. We've got our groups table, flow constraints, customer demand table. Each of those sheets in the Excel file have been processed. And if we move back into our CosmicFrog model, then we can see that all those Anura tables are now populated. Now, often we want to be able to read data in from our model, make changes and transform that data, and then write it back into the model itself. So if we take an example here, we want to read in our customers table, and we want to set the column for geographic risk score equal to 5 for all records, and then we want to write that back into the table. So let's take a look at how we can do that within our script. We want to bring the data back from that table into a pandas data frame called df customers. We can very easily do that with a model function called read table, and that table we can specify as customers, and this will read the contents of that table back into our new data frame, and then we can simply print out the contents of that data frame. So now let's run that script. That will connect to our CosmicFrog model, and then we can see that it's read all of the data from the customers table in our model database, and it's printed that data out that's now in that data frame. So now what we want to do is update the value for geographic risk score in our data frame. So here what we're saying is in the df customers data frame, this column for geographic risk score, we're going to update that to the value of 5. So now let's run that script. It will read in the customers table from the model. It will apply the change to geographic risk score, and then it will print out that data frame, and we can see that that is now being applied to geographic risk score. All records are set to 5. So finally, we want to take the changes to this data frame and write them back into the customers table within our model. So we can do that easily with an upsert function. We can see here that we're not using upsert CSV or Excel. We're not bringing the data from a file. This is updating the table directly from a data frame. So we can specify which table that we want the data to be upserted into, which is customers. And then we can also specify the data frame that we want to upsert it from, which is our df customers data frame. So now if we run our script, it's going to connect to the model. It's going to read all the data in from the customers table, It's going to apply the changes to the table, the geographic risk score equal to 5, and then it's going to upsert that new data back into the database. So we can see that's happened successfully, and all of the rows in the customers table have been updated. And then if we go back into our model in CosmicFrog, we can see that the geographic risk score is now set to 5 for all of those records. So that's a nice example of how we can read data in from models, transform that data, and then be able to easily write that data back into our model. Other useful functions we've got for working with data are the ability to use the read tables function, and this will allow us to read in multiple tables at a time into a dictionary. We have a function for write table, and this allows us to write data into tables in the database, but this can be done from a data frame, but also other iterable objects, so things like dictionaries and lists. And then finally, we have a clear table function, and this allows us to very simply go and clear all the data within a defined table within our model. In Chapter 3, we're going to explore using SQL statements as part of our script. We're going to look at how we can read data from the model using a SQL statement, and also how we can update and delete data directly within the model using a SQL statement. In this example, we want to read in from the customers table all the customers, but only where the region is equal to Texas. Let's take a look at how we can do that in a script. So we're going to read this into a data frame called Texas customers, and we can use a model function called read SQL, read SQL, and this will allow us to pass a query that will be executed, and the results will be put into that data frame. So we'll add into the function the SQL. This is going to select all records from the customers table where the region is equal to Texas, and then we can just quickly print out that result. So if we run that script, that's going to connect to the database, it's going to execute the SQL, and it's going to return it to this data frame, and we can see here that it's printed all of the customers that are in Texas. Now we're going to learn how to update data in this table based on a condition. So in this example, we want to set the status column to exclude, but only where the region equals New York. So let's see how we can implement this to the script. We can use a function model execute SQL, execute SQL, and this will execute any query that we define against the model database. So let's add in our SQL query to this function, and this is going to update the customers table, and it's going to set the status column equal to exclude, but only where the region is equal to New York. So if we run this script, it will connect to the database, it will execute that SQL against the customers table, and now it's completed, we can go to the CosmicFrog model, and we can see that where the region is equal to New York, we can see that the status has now been updated to exclude. And finally, if we wanted to just delete those customers completely rather than exclude them, then we could just update our SQL query, and this will delete from the customers table where the region equals New York. In Chapter 4, we're going to explore functions that allow us to understand the model schema. So we can list out tables, list out columns within tables, and also understand key columns, which are important for upsert, where it's looking to match records on unique keys. Now let's look at using the CosmicFrog Python library to get some information about the model. We want to return a list of all columns in the customer demand table. So we can start by defining a variable, column list, and then we can simply say model.getColumns, which is a function, and then we can define the customer demand table. And then let's simply print out the list of columns that's returned. So if we run this function, we can see that it's connected to the model database, and that has now returned a list of all the columns that are in that customer demand table. Another useful function is get key columns. So key columns are used to identify unique records for upsert. Where they exist, they'll be updated. Where they don't exist, they'll be inserted. So we can use exactly the same format here, but we're just using a different function called getKeyColumns, and then we're going to print those out into this new variable keyColumnList. So again, we can run our code, it will connect to the database, and we can see it's printed out all the columns in customer demand, but it's also printed out these three key columns, so customer name, product name and period name, will be used to identify unique record, where existing records will be updated and new records that don't exist will be inserted. There are two other very useful functions when we're looking at getting information about the model. There's get table columns from model, and this will actually bring back all of the columns, including any custom columns that have been defined, rather than just the columns that are in the Anura data model. And then we also are able to bring back a complete list of tables. And we can define whether we just want input and or output tables. And we can also apply a technology filter that allows us to bring back just optimization or simulation or Greenfield or transportation optimization tables. So in this final chapter, we're going to bring together everything that we've learned. We're going to create a single script that's going to upsert the initial customer data from the two different CSV files. It's then going to upsert the rest of the model data, which is held in an Excel file, and the data is in multiple sheets. We're then going to read that customer data back out the model. We're going to update the geographic risk column, and then we're going to upsert that changed, updated data back into the model. And then finally, we're going to execute an update SQL statement to exclude all customers which are in the region New York. So we're going to build this script in Atlas on the Optologic platform. So the first thing we'll do is we'll create a new file, and we'll call this model update script.py. And the first thing we'll do is we'll start to set up our connection to the CosmicFrog model. So let's go to CosmicFrog, and the first thing we want to do is create a brand new model. So we'll call this model my scripting model. We'll give it the same description. I'm going to create a completely empty model. We're not going to start with a template. So we'll click create model. That new model has been created, and then all we need to do in our Atlas script is specify that new model name that we've just created as the one that we want the script to connect to. So now we've made the connection to the model database, what we can now do is upload the mycustomers.csv file into the customers table. So we'll use the model.upsert.csv function. We'll define the table that we want it to be upserted into, which is customers, and then we want to reference this file. We can see in the tooltip there that it shows us the file path. We can also easily right-hand mouse click on the file, select copy path, and then we can define where that data is going to come from. The next thing we want to do is to also take the updated customers.csv file and upsert that to the customers table. So this will be using exactly the same function to put it in the customers table. The only difference this time is we're going to copy the path of that other data file, updated customers.csv. So now we want to upload the data for the rest of the tables in the model. This is going to come from my model data.xls. This is a multi-sheet Excel file where each sheet represents the table we want to upload. So we can use the model.upsertXL function, and the only parameter we need to pass in is the name of the Excel file. So again, we can copy the path and we can put that into the function. And where it recognizes a sheet that matches a table name, this function will automatically import the data from that Excel sheet into that model table. So now we want to update the geographic risk score column and set the value for 5 for all records in the customer table. So the first thing we're going to do is we're going to import that data from the customers table, and we're going to be using the model.readTable function to do that. And we're going to be loading that data into a data frame called df customers. And once it's in that data frame, that enables us to work with it within our script. So now we can do a basic data transformation, and we want to set the value of geographic risk score equal to 5. So in this line here, we're updating all records in the df customers data frame to set geographical risk score equal to 5. And now we've made that change, we want to put the data back into our model into the customers table. So here we're going to use the model.upsert function. It's just upsert because we're not taking it from a file, we're taking it from the df customers data frame, and we're inserting the data, upserting the data from that data frame into the customers table. And then finally, we want to make a direct change to the data in our model. We want to change the status column in the customers table, and we want to set it to exclude for all customers that are in the region New York. So to do this, we'll use the model.executeSQL function, and the parameter that we pass is the SQL statement that we want to execute. So we can see here that we want to update the customers table, setting the status column equal to exclude, but only where the region is equal to New York. So now we're ready to run our script. In Atlas we have two options. We can run in Studio, which runs it in a debug mode where we can see everything that's going on, but we can also run it as a job. And when we deploy these scripts, they'll be run as jobs, and this means that they'll hyperscale, so they'll all run in parallel, and we'll also be able to select different resource sizes. So where this script is doing heavy data processing, for example, where we might need lots of CPU or lots of memory, then we have immediate access to all of that as a core part of Optologic's SaaS platform. So now let's run our script in Studio. So now we can go back to our CosmicFrog model, and we can see that all of the relevant tables are populated in the Anura model. And we can also see in the customers table that any customers that are in the region New York have been set to exclude. And we can also see that the column geographic risk score has been updated to 5 for all records within that table. So now you have all the knowledge to use the CosmicFrog Python library to build scripts against your CosmicFrog models. From here you can continue to extend it for any use case, leveraging the full power of Python using Atlas on our platform.